Let us see the transfer characteristics of JFET. Yeah. So what is meant by the transfer characteristics? It is nothing but the relation between the input and the output, right? So in case of FET, we have input voltage, that is control voltage as gate to source voltage, right? We are wiring gate to source voltage, and according to this value of the gate to source voltage, right, what we have, we get this varying ID current, right? So this was the drain to, yeah, drain to source voltage, and drain current characteristics means drain characteristics run between drain to source and drain current, right? What we see in this characteristic when VGS is varied, IDSS or ID value of ID current, yeah, that is varied, right? Now we will plot the transfer characteristic, that is between the gate to source voltage and drain current ID, right? So what we see in case of this, yeah, N channel FET, right? As soon as we increase this gate to source negative potential, right, from this zero, so what we can see is that there is reduction in this current, right? So this current reduces, right? So the maximum value of the current is IDSS, mean gate to source voltage is zero. So maximum saturated voltage, saturated current, sorry, saturated current is IDSS, or short drain to source current, that is IDSS, that is having the maximum value, right? When gate to source is zero. But as soon as gate to source voltage is made more and more negative, value of IDSS or IDE is decreasing, and it will become zero when gate to source voltage. When gate to source voltage is equals to pinch off voltage, right? So no current will flow. So this will indicate the transistor is cut off, transistor is operating cutoff region, and this is what the linear region. And when VG is equal to 0, IDS is maximum, ID value is maximum, that is equal to IDSS, right? So this is the saturation region. So this is what the transfer characteristic is. Yeah, yeah. So yeah, if we put the equation of the transfer characteristic, we get this relation as ID equals to IDCS into 1 minus VGS upon VP square, right? That we have already mentioned, right? Okay. So if in case if we put uh, VGS equals to VP by 2, VGS equals to VP by 2 within this equation, so we will get value of ID equals to IDSS by 4, right? And if we try to find out the relation of VGS in terms of ID, so we will get a value of VGS equals to VP into 1 minus under root ID upon IDSS, right? So here, if we put value of ID, right, equals to IDSS by 2, so we will get value of VGS nearly equals to 0.3 times pinch of voltage,